this video, we're going to be looking at how to find the X values or the cutoff scores given a particular probability or percentage using the normal distribution. Several things I want to remind you about is that remember that the area under the curve corresponds to the probability or to the given percentage. Also, sometimes in these questions, it'll say something like, find the 80th percentile. And so I want to remind you what a percentile means. Percentile means that's the percentage or the probability of the data values that the data values fall below that cutoff score. It's important to realize that percentiles describe the percentage below the cutoff score. We're all going to be using technology to do these calculations, and we're going to be using the website which is referenced there, so you may want to go ahead and get that opened up on your computer. So, beginning with the first example. According to the American College Test, results from the 2004 ACT testing found that students had a mean reading score of 21.3 with a standard deviation of 6. Assuming the scores are normally distributed, find the 75th percentile. If you're in education, this is kind of an important idea because a lot of times with any kind of standard testing, on the score report, it'll say that a particular child was in the 75th percentile or in the 90th percentile. And as an educator, you may have to explain to the parent what that means. But as you're looking at this problem, again, notice that they do have to tell us again that it is normally distributed, just like they do. We have to know the distribution is normally distributed. We have to know the mean of the distribution, which is given, and we have to know the standard deviation. So again, as shorthand, if you've looked at the other videos, we can still say that X is approximately normal with a mean of 21.3 and a standard deviation of 6. Now the difference here is that basically if you want to see it, we were saying that the probability that X is some number, and I don't know what that number is, corresponds to the 75th percentile or to 75%. So visually, here's what that means. Okay, you can still have your horizontal number line. You still have your bell-shaped distribution. We know that our mean is 21.3. Now, again, the idea of the 75th percentile means that 75% of the ACT scores fall below the value we're looking for. Okay, so remember on this normal distribution that we start out at the left and we're like at 0%, and we go all the way up, we're at 100%. The mean is in the middle, so that would be the 50% mark. So 75% is going to be somewhere here on the left. And I don't know what value that is, but we have 75% or 0.75 of the data values below that value. So this is a little bit different. We start out knowing the percentage, and we're trying to backtrack to the cutoff score or the data value. Okay, so this is called the inverse normal distribution. So we're going out to a different website. Okay, let me get to it. We have to enter the area, which for us is the 75%. The mean, we were told, was 21.3, and the standard deviation was 6. Okay, and we're looking for the amount below. Okay, so when I click the box next to below, it enters the value into the box for me, 25.345. Okay, so our cutoff value would be 25.345. So the 75th percentile corresponds to an ACT score of approximately 25 or approximately 25.3. You usually see it as 1 decimal place. All right, moving on. Men's heights are normally distributed with a mean of 69 and a standard deviation of 2.8. The standard casket has an inside length of 78 inches. A manufacturer of caskets wants to reduce production cost by making smaller caskets. What inside length would fit all men except the tallest 10%? Okay, so again, notice they start off telling us that men's heights are normally distributed. They tell us the mean is 69 inches, and they tell us the standard deviation. Okay, now they tell us the length of a standard casket. We don't necessarily need to know that, but we want to basically figure out how long or how big we could make the casket so that it fits all men except the tallest 1%. So we know that our variable, the men's heights, is approximately normal with a mean of 69 inches and a standard deviation of 2.8 inches. And we're looking for the probability that our casket fits all but 1%, but we don't know what value that is, okay? All right, so let's look at a picture. It's almost easier to look at a picture than it is to try to write it out in symbols. Okay, so we have our bell-shaped distribution, our means in the middle, which is 69 inches, and it says we're going to make caskets that fit all but the tallest 1%. So we need to think about where that cutoff is going to be. So again, if you're thinking about this, typically on the left, you have low values. So these are going to be men that are short, and we're going to work our way to the men that are tall. So if I want to exclude, leave out the tallest 1%, okay, that means I'm going to have a cutoff here on the right-hand side, but I don't know what height that corresponds to. That would be the tallest 1%. Okay, so notice in this case, the interpretation is really, we're looking for that cutoff that's above a particular value. So if we go out to the website, again, our area here is 1%. The mean was 69. Yep, mean is 69. Make sure you get the right numbers in there. 69.0. Standard deviation is 2.8. And this time I want to be above a particular value. And again, notice how the picture at the top looks similar. It shows that we're cutting off this little grayed out region here on the top because we're cutting off the tallest. So it's 75.515. Okay, so my X value, my cutoff score is 75.5. Did I say 515? Make sure. 515.15. So the casket maker could just about reduce the length of a casket by roughly 2 inches or maybe 2.5 inches and have it at 75.5 and still be able to fit most men. So anybody that was 75.5 inches tall would probably have to special order a casket if they decided to go that route. All right, number 3. An advertising company plans to market a product to low-income families. A study states that for a particular area, the average income per family is $24,596, and the standard deviation is 62.56. If the company plans to target the bottom 18% of families based on income, find the cutoff income. And it says to assume that the average income per family is normally distributed. So again, notice they tell us that the average income or our variable is normally distributed. They told us that the average income per family is $24,596 and the standard deviation is 62.56. 56, and it tells us that the company is going to target its advertising to the bottom 18%. So here's what we know. We know that our variable X is approximately normal with a mean of 24,596 and a standard deviation of 62.56. We're looking for the cutoff score, so we want to know the probability that X is less than some particular number and that's the bottom 18%. Okay, so let's look at a picture. Okay, we have our horizontal axis, the bell-shaped curve, the mean is in the middle, which is $24,596. And we want to exclude the bottom. So again, if you think about how this reads, we read left to right. So we're going to basically be reading bottom to top. And so we're going to exclude the bottom 18%, which in decimal form is 0.18. So I'm looking for this income amount right here. Okay, so I'm going out to the website. My area is 18%. My mean is 24,596. My standard deviation is 62.56. And I want to be below that number. Okay, because I'm cutting off the bottom. So it would be 18,870. If you round it to the nearest cent, it's going to be 12. 18,870, 12. Okay, so my cutoff score is $18,870.12. Okay, so basically anybody below that income amount would be targeted for advertising by this particular company. Men's heights are normally distributed with a mean of 69 and a standard deviation of 2.8. If Miss Ralston designs a house so that all the doorways have heights that are sufficient for all men except the tallest 5%, what doorway height would be used? Okay, so again, notice that they tell us that it is normally distributed. We have a mean of 69 inches and a standard deviation of 2.8 inches. And we want to make doorway heights that will fit all men except the tallest 5%. Okay, so here's what we know. We know that our variable men's heights is approximately normal with a mean of 69 inches and a standard deviation of 2.8 inches. We want to figure out the height that fits all men except the tallest 5%. So I'm going to draw my curve, horizontal axis, bell-shaped distribution, mean in the middle, which is 69. Again, if you think about what we're doing here, in terms of the curve, we work from short to tall, and I want to exclude the tallest 5%. So tallest is going to be up here at the top, and we're going to exclude 5%. So I'm trying to find this cutoff value. Okay, as a decimal, that's going to be 0.05. So we go out to the website and we enter the information. Okay, my area is 5%. My mean, let's see, I forgot what that was. My mean is 69. My standard deviation was 2.8. And I want to be above the cutoff because I want to exclude the tallest 5%. So I have 73 73.607. Okay, so my cutoff score is 73.607. So basically, my door heights need to be roughly 74 inches to ensure that I include the tallest 5%. So my doorways would need to be approximately 74 inches. And one more. In a recent study, the Centers for Disease Control and Prevention in Atlanta reported that the diastolic blood pressure of adult women in the United States are approximately normally distributed, with a mean of 80.5 and a standard deviation of 9.9. Okay, so notice they tell us that it's approximately normally distributed. We have a mean of 80.5 and a standard deviation of 9.9. So here's what we know. We know that our distribution is approximately normal with a mean of 80.5 and a standard deviation of 9.9. And we want to find the 85th percentile. So I would have my horizontal axis, bell-shaped distribution. The mean is in the middle, which is 80.5. Remember, the mean divides at 50-50. We're trying to find the 85th percentile, remembering that percentile means the percentage below. So we know that from the beginning to the mean is 50%. So 85% is going to be somewhere over here. And by definition, that's below. Okay, so this would be the 85th percentile, which writing 85 as a decimal would be 0.85. So we're looking for this cutoff score. Okay, so going out to our website, in this case we want 85%. My mean was 80.5. My standard deviation is 9.9, and I got to be below, by definition, of 85% percentile. I need to be below, and it comes out to be 90.761. So a woman who has a diastolic blood pressure of approximately 91 would be, or 90.8 would be in the 85th percentile. All right, that's all of the examples. Hopefully this is helpful for you as you think about how to find the cutoff scores for a given percentage using the normal distribution.